Hello everyone, this is me Sachin Sarave again. Today we are going to discuss the instrumental method for setting out simple circular curve, and in this lecture we will discuss what is instrumental method. And in previous lecture we have discussed what are the methods, what are the chain type methods for setting out simple circular curve, and I've given one example of long chord method. And today we're going to discuss the instrumental method, which is also known by the method of Rankine's method or deflection angle method. So before going further, we will understand its field procedure, or the procedure in which how this method works. So as we all know, we have to first place the long chord, that is AB, and after AB we have to mark the point T1, that is first tangent point. Then at T1 we have to place the instrument, that is theodolite, and set the angle delta 1, which we will get after calculation. And this delta 1 mark one chord, and in this chord mark our first chord length, that is L1. After marking L1, on the same point T1 we have to mark second angle delta 2, which I have already calculated. I'll show you how to calculate that. And after that, on delta 2 line we have to mark second chord L2, but we have to mark that chord from the point where L1 ends, not from the T1 point. We have to mark that chord from this point. So if L1 is 5 meter and L2 is 10 meter, 5 meter will be from this point to this point will be 5 meter, and next L2, that is 10 meter, will be start from here. The 10 meter will start from here. So this distance is L2, which may be any number. I've just assumed 10 meter. Okay. So after this L2 we have to mark our third angle, that is delta 3, again from T1, and from that AB chord, from this AB chord. And after marking delta 3, after plotting delta 3, we have to mark our line, and on that line we have to mark our third chord, that is L3. Again this L3 will start from the point where L2 ended, not from this point. It will start from this point. Okay. And so on, number of angles we can set the method. So this is method of Rankine's method. Why I've described this method first, because for understanding the derivation we should know the importance of this delta. Okay. So we'll go to our PDF again. So instrumental method, Rankine's method. So AB, initial tangent, BC, forward tangent. This is O, origin. This is radius. This is radius. This is our delta 1. We have to find out the formula. We have to derive the formula for delta 1. That will be the derivation. So in the whole the method, two things are more important. First one is delta. Second one is L. Okay. So for derivation purpose, we will just assume the triangle, this triangle. Okay, this triangle. Okay, and in this triangle we say that T1 P1 is L1. So this is T1, this point is P1. So T1 P1 length is L1, and this P1 P2 length is L2. Okay, so P1 is the first point on the curve. T1 P1 is the length of the first chord, and as I said earlier, I'll just zoom out. This angle T1. Okay, before going further, we should understand the angle of circle is 360 degree, and this is 2 pi is a perimeter of the circle. So by considering this rule in this triangle, we say that angle T1 O P1, okay, this triangle divided by this length should equals to 360 divided by 2 pi. This is basic rule of geometry. We have already studied that thing in initial purposes. Okay, and again angle T1 O P1 is equals to angle T1 O P1 is equals to twice the angle delta 1. Okay, this is again property of triangle. So angle T1 O P1 is equals to twice delta 1. So I have substituted that value here. T1 O P1 is equals to twice delta 1. I've sent that L into multiplication, and after rearranging the things, I've got the formula delta 1 is equals to 360 degree into L1 divided by 2 into 2 pi r. Okay, this 2 I've sent here, and this angle, the answer is in degrees. So if I have to convert the degree into minutes, I have to multiply it by 60, and after multiplying it by 60 and after doing some calculation, the formula for delta 1 becomes 1718.9 into L1 divided by R, and the unit will be minutes. Okay, so this is simple derivation, no need to make it complicated. I've just drawn one simple diagram. In that diagram, I've considered the first chord that I've shown in presentation. This is first chord. This chord, and we have considered the triangle T1 P1O or T1O P1. That length is L1. This angle is twice delta. Here I've written. I've just put it that formula in perimeter formula, and I've got that thing. Okay. Similarly, I can calculate the delta 2. For delta 2, the value will be replaced, L1 value replaced by L2. So delta 2 will be 1718.9 into L2 divided by R. Units again will be minutes. So this process go on, and I can find the number of angles delta n. Okay, and if these formulas are for if angle is given in degree, sorry, if the degree of curve is given at angle. And for solution purpose, for finding out the data or for calculation of data of Rankine's method, these simple steps I've given. So you have to calculate the data according to this step. This will be easier. So first thing is tangent length, second thing is curve length, next change of first tangent point, change of second tangent point, initial subchord, number of full chord, final subchord, deflection angle for initial subchord, deflection angle for full chord, deflection angles, deflection angle for final subchord, arithmetical check, data for field check, and setting out table. This thing is very important, setting out table. I'll explain the setting out table in next video. So that's it for today. Thank you.